Can you teach an old robot new tricks? A handful of college students are using assembly-line robots to help NASA prove it's possible. In the future, teams on the ground will be able to telerobotically repair and refuel spacecraft and change their orbits. At least, that's what employees of the Satellite Servicing Capabilities Office at NASA's Goddard Space Flight Center in Greenbelt, Maryland, are working toward. Inspired by astronaut servicing of Hubble Space Telescope, the team is creating a robot system that could autonomously capture and then service a spacecraft. Not an easy feat. NASA Goddard Robotic Demonstration and Test Manager Brian Roberts tapped into academic resources across the country to help solve some of the challenges. He recruited professors and students from several universities, including University of Maryland, Rensselaer Polytechnic Institute, Johns Hopkins University and Case Western Reserve University. We've kind of picked the unique skill sets that they have and said, for example, here are the challenges we're having with cutting an insulating blanket on a satellite in space. Look at techniques we can use to make that easier, Roberts said. Satellite servicing robots must be able to cut through foil insulating blankets to access and repair or replace instruments inside the spacecraft. Lack of gravity complicates the process because blankets begin to move as soon as they are cut, obstructing the process, Roberts said. Professors and students at Johns Hopkins University in Baltimore, Maryland, found a solution using delicate robotic technology they previously developed for surgical procedures. The satellite servicing team is evaluating this technique in their proposed flight system for the robots. Each university team plays a similar role. The largest cohort of students comes from West Virginia University in Morgantown, which joined the project in 2010. Currently, about a dozen undergraduate and graduate students work on campus and at the West Virginia Robotic Technology Center WRTC in Fairmont alongside professors and a full-time staff of engineers. They work hand in hand with Goddard, tackling some of the toughest challenges. One of the challenges is that engineers sometimes do not design space robot arms to function on the ground. Their motors cannot lift them against Earth gravity, making development and testing with these machines nearly impossible. The team substituted industrial robots, such as those used to assemble cars. Their larger motors easily lift their weight against Earth gravity, but the assembly line automatons are not a perfect stand-in. Their industrial joints move more stiffly and they exert more force than space robots. Engineers bolted the largest robots into 4 tons of metal to stabilize them, but they still rock the building at full force. Goddard and WRTC co-developed software both to make the automaton simulate their space cousins' more delicate actions, and to perform servicing-related tasks. One of the biggest challenges in a potential servicing mission is capturing the client satellite. Having humans on the ground control the robotic capture of a spacecraft is incredibly difficult and risky, in part due to a communication delay of a few seconds as signals travel from the spacecraft to the ground. It doesn't sound like much, but those few seconds can mean the difference between capturing a spacecraft and flying past the moving target. NASA engineers are therefore working on software and technologies that would empower the robot servicer to perform an autonomous capture. The industrial robots at Goddard and WRTC help the engineers practice and hone these technologies.